In this lecture, we are going to study about conditional probability. This is one foundational concept in probability which is used in Bayes' theorem. So, to understand Bayes' theorem, we should know what is conditional probability. It is very important concept in probability. Let us see what is conditional probability, right. So, we were talking about dependent and independent events, right, and we talked about mutually exclusive events as well. So, let us try to understand what is conditional probability. Let us say there are two events A and B, there are two events A and B. I am trying to find out the probability of event B given that event A has already happened. There could be chances that I am finding out the probability of event B to happen. What is the chance of event B? What is the probability of event B given that event A has already happened, right. So, these kind of probabilities are called as conditional probability, right. So, to understand better, see if there are two events E1 and E2, what is the probability of event E1 to happen given that E2 has already happened, right. This is conditional probability and we denote it by P of B by A. We do not say it by here, this is read as given that. So, the meaning of P of B by A is probability of event B given that, this line indicates given that event A has already occurred. That is the conditional probability, right. So, what is the formula of conditional probability? Conditional probability is nothing but P of B by A. What is the meaning of this P of B by A? It means what is the probability? We are trying to find out the probability of event B to happen given that event A has already occurred, right. So, P of B by A is nothing but what is the probability of A intersection B by P of A. We know event A has already occurred and we also know the common term that both events, what is the intersection of A and B, right. So, this is the formula for conditional probability. See, P of B by A is the probability of occurrence of B given A has already occurred. What is A intersection B here? Probability of occurrence of A and B together, and P of A is the probability of occurrence of A, right. This need not be always B by A, it could be P of A by B as well. Let me just explain you. See, suppose in this case I told given that A has already occurred, you are trying to find out the probability of event B to happen. Suppose event B has already occurred and you are trying to find out what is the probability of event A. In that case it will be P of A by B. It means not A by B, we say A by B, but actually it means given that. So, what is the probability of event A given that event B has already occurred is nothing but here it will be P of B and here it will be P of A intersection B. So, this is the conditional probability, right. So, wherever there are events where there is a dependency between two events, right. Suppose event A has already happened, its outcome has some reflection or it has some significance in the event A outcomes. That time we have to use conditional probability, right. So, we can write it P of B by A is equal to P of A intersection B by P of A. Okay, let us try to understand what is conditional probability with a simple example. A teacher gave her students two tests, one on mathematics, other on science. Okay, 25% of students have passed both the test maths and science and only 40% of students have passed only the math test. See here, try to understand the concept. So, 25% have passed both. So, M intersection S is given as 25%, that is given to us. M intersection S is 25% and what is the probability of only M is 40%. Only M is 40%. The question is, what is the probability that a student has passed the science test given that they have already passed the math test? Okay, so there is a student, yes, let us say he has already passed the math test, he has passed the math test. Now, what is the probability that a student who has already passed mathematics also has passed science? This we are trying to find out. Okay, what is the probability that student has passed the science test given he has already passed the math test? So, using this data we try to find out the probability. So, let us see what I am trying to do. Probability, let A be the event that student passed math, B be the event that student passed the science test. Probability of passing both the test A intersection B is 0.25. Probability of passing only test A, that is math test, is 0.40. So, by using the probability conditional probability concept, we know P of B by A. I am trying to find out the P of B. I am trying to find out P of B given that he has already passed the math. So, the formula we know, that is P of A intersection B by P of A. So, from this data 0.25 by 0.40, if you simplify this, you get somewhere around 5 by 8. We get around 5 by 8, that is what, right, sorry. So, 5 by 8, that is 0.625. Okay. So, the probability that a student will pass the science test given that he has already passed math test is 0.625, right. So, this is an application of conditional probability. I hope you understood this. When an event has already occurred, what is the probability that another event will happen, right. So, this we try to use it in the Bayes theorem, the most important concept. Bayes theorem, it has lot of applications in machine learning. Directly it is used in naive Bayes classifier. We have a classifier, we have a classification technique called naive Bayes, right. So, this is directly based on the Bayes theorem. So, there is a direct machine learning model called as naive Bayes classifier which uses Bayes theorem, and Bayes theorem again uses conditional probability, it uses conditional probability. Let us try to understand what is Bayes theorem, right. It is also called as Bayes law or Bayes rule or Bayesian reasoning, right. So, determines the probability of an event under uncertain knowledge. Whenever there is uncertainty, we talk about we apply Bayes theorem there, right. It relates conditional probability and marginal probability of two random events, and it was named after the scientist Thomas Bayes. Okay. So, what is this Bayes theorem? It is a powerful formula used to find the probability of an event based on prior knowledge or conditions. Why prior knowledge? You see, when in conditional probability, what I am saying, when I write P of B given that A, P by A, what does it means? Probability of event B to happen given that already you know a prior knowledge that A has already occurred. A has already occurred. So, when you know that A has already occurred, right, we are trying to find out probability of B, event B. So, that is what Bayes theorem is, a formula used to find out the probability of an event based on prior knowledge, right. So, it connects conditional probabilities and allows us to update beliefs when known evidence are observed. Okay. So, what is the formula of Bayes theorem here? See, we will try to understand this. I will just try to explain you what is conditional probability. So, if I say P of B by A is nothing but P of A intersection B by P of A, we know this formula. From this can I write P of A intersection B is equal to, I am just equating P of A intersection B equal to, I am multiplying these two. So, it becomes P of B by A into P of A. What is this? What is this? I am saying it as equation 1. What is this? Given that event A has already occurred, what is the probability of event B? Now, second case, let me talk about. What is the probability of P of A by B? Meaning, given that event B has already occurred, what is the probability of A? So, same formula we use here, A intersection B by P of B. From this, can I write P of A intersection B is equal to P of A by B into P of B. I have just multiplied these two and equated it. Now, if you observe these two equations, equation 1 and 2, are they both not equal? See, these both are equal. When these both are equal, I can equate these two values also. So, therefore, it becomes P of B by A into P of A is nothing but P of A by B into P of B. From this, if I want to find out what is the probability of event B to happen given that A has already occurred is nothing but P of A by B into P of B by P of A, right. So, this is the formula of Bayes theorem. This is the formula of Bayes theorem. Another formula also you can derive if you want to find out the probability of event A given that B has already occurred. So, you just shift it here. So, it becomes P of A by B is nothing but P of B by A into P of A by P of B. So, this also could be Bayes theorem. Depending on the problem, anything is same, you can use it, right. So, this is the formula of Bayes theorem, that is what we have seen. P of A by B is equal to P of B by A into P of A by P of B, right. So, we are trying to equate the conditional probability equations and trying to derive the formula for Bayes theorem. So, this is the formula for Bayes theorem, very important, right. So, in this formula there are different terminology we use it here. P of A, what is the probability of P of event A to happen given that B has already occurred, right. Given that B has already occurred, this is called as posterior. This probability is called as posterior. Okay. Next, what is B by A? It is likelihood, it is called as likelihood. See, what is definition of posterior? Probability of A being true given B is already true. I know the previous knowledge that B is already true. This is called posterior. What is likelihood? Probability of B being true given A is true. Probability of B being true given A is true. What is P of A? It is called prior, because we already know. See, we already know what is P of A, the probability of A being true, this is the knowledge. And this part P of B is called marginalization, this is called the margin, right. Probability of B being true is the margin. So, in Bayes theorem we call these four terminology, we need to know this when we study about Naive-Bayes classifier. So, this is called the posterior, this is called the likelihood, this is the prior, and this is the margin, components of a Bayes theorem. Okay. Let us see what are the different applications of Bayes theorem. Bayes theorem is widely used in machine learning and AI, right. Other applications include, it is used in robotics to decide the robot's next step based on the prior moves, right. Next, weather forecasting, predict weather using past and current data. Okay. Monty Hall problem is one problem, we solve probability puzzles and decision making problems, right. So, this is a very limited set, there are a lot of applications of Bayes theorem. What is law of total probability? There is one more important concept we need to understand when we study Bayes theorem, that is law of total probability. What is this? See, law of total probability is used to find out the overall probability of an event by breaking down into different scenarios. Okay, breaking down into different scenarios. Let us see what is the formula for that. Let B1, B2, so on, Bn be a partition of sample space. Okay, simple example, when I am rolling a die, what is my sample space? 1 to 6. What is an event here? I have an event to get only odd numbers. So, I have an event even with only 1, 3, 5, it is a event. I have another event with output as even numbers, that is 2, 4, 6, right. So, there are two different events here. So, combination of all those probabilities will become my sample space. So, let B1 to Bn be partition of a sample space, they are mutually exclusive and exhaustive, and let A be any event. To find out A event, it is nothing but summation of 1 to n P of A by Bi into P of Bi, right. So, P of A is nothing but P of A by B into P of B, right. When the events are mutually exclusive, we use this P of A equal to, but if there are multiple events, let us say there are B1, B2, B and so many events, in that case what will happen? P of A will become simple as like this. See, P of A will become, P of A is nothing but P of A by B1 into P of B1 plus P of A by B2 into P of B2 and so on. So, depending on the number of partitions, we keep applying this. We will see this, we will see what is total law of probability using a simple example, and then we will see its application even in Bayes theorem, right. It is used in Bayes theorem to compute P of A or P of B depending on the context, right. Here I have given the formula to calculate P of A, it depends on the problem.